We are going to talk in section 1.1 about two different kinds of reasoning. The first one we're going to look at is inductive reasoning. With inductive reasoning, this is the process of arriving at a general conclusion based on observations of specific examples. So it is from specific to general. Next, we will look at deductive reasoning, and it is the process of proving a specific conclusion from one or more general statements. A conclusion that is proved to be true by deductive reasoning is called a theorem. With deductive reasoning, we go from general to specific. Let's look at a couple of examples. First, we'll talk about inductive reasoning. Although inductive reasoning is a powerful method of drawing conclusions, you can never be absolutely certain that these conclusions are true. For this reason, the conclusions are called conjectures, hypotheses, or educated guesses. A strong inductive argument does not guarantee the truth of the conclusion, but rather provides strong support for the conclusion. If there is just one case for which the conjecture, hypothesis, or educated guess does not hold, the conjecture is false. Such a case is called a counterexample. All right, here are a couple of examples we're going to look at inductive reasoning. Inductive reasoning can be helpful when you're trying to identify a pattern and then predict what comes next. This first pattern of numbers goes from 3 to 12, 21, 30, 39. You usually are looking, at least at first, is there some common number being added or is there some common number being multiplied? Well, in this one, it's being added. If you add 9, you get from 3 to 12. If you add 9 again, you get from 12 to 21. Add 9, you get to 30. Add 9, get to 39. So I'm going to now believe from these individual specific cases that I can always add 9 to get to the next one. So I'll add 9 and I get 48. By the way, this is called arithmetic because I did a common adding. Looking at the second example, it goes from 3 to 12. Well, we saw that before. But then it goes from 12 to 48, so it's getting much bigger, much faster. And from 48 to 192, 192 to 768. All right, this time you're multiplying by the number 4. That takes you from 3 to 12, from 12 to 48, 48 to 192. 192 times 4 is 768. So to figure out my next one, I will multiply 768 times 4, and I get 3,072. Once again, I went from the specific to a general conclusion. This one said each term is found by multiplying 4 times the previous term. All right, the sequence does not have to be numbers, it can be patterns. So if I am trying to predict the next drawing in this, well, I noticed right away that it is circle, square, circle, square. So I believe the next one will be circle. I also see that each one of these has an X drawn in it and then some dots. Well, what's happening with the dots? Obviously, they're moving to the 4 little pieces, whether they're 4 pieces of a circle or 4 pieces of a square. And it looks to me like they are rotating counterclockwise because the single dot went up, the 2 dots went to the side, the 3 dots came down to the bottom. Then I look at the next one and it looks like once again it has rotated and the 1 has gone to the left, the 2 has gone up to the top, and the 3 has gone to the right. and so on. So if I take this last picture that's given and I rotate one position. The single dot will go in the right-hand side. The two dots will be on the bottom, and the three dots should be over here. Okay, I don't have a very pretty drawing, but I think you get the idea. Now, deductive reasoning, this is the one that gives you a process for providing a specific conclusion for one or more general statements. So with this one, we look at something general, which we believe to be true, and then we draw a conclusion based on our general statements. Here's a couple of examples. The first one, two people are playing Scrabble, one player to another in a Scrabble game. You have to remove those 5 letters. You can't use TEXAS as a word. Okay, how is that deductive reasoning? First, there's a general statement, all proper names are prohibited in Scrabble. Next general statement, Texas is a proper name. Conclusion, therefore, Texas is prohibited. So we went from general statements to a specific one about the word Texas. In the next one, it says advice to college freshmen on choosing classes, and this comes from a How to Survive Your Freshman Yearbook. Quote, never sign up for a 7 a.m. class. Yes, you did it in high school, but mom was always there to keep waking you up. And if by some miracle you do make it to an early class, you will sleep through your lecture when you get there. All right. So, general statements. All people need to sleep at 7 a.m. Another general statement, you sign up for a class at 7 a.m. Conclusion, therefore you'll sleep through the lecture or not even make it. Now there's one little issue about this. This conclusion seems to be very valid based on these general statements, but are the general statements true? And so that's something that can be explored much further. All right, I simply wanted to expose you to a little bit of investigation of both inductive and deductive reasoning. Now we're just going to move on to section 1.2. It is about estimation. And when you see some text like this, I have lifted it from your textbook to our video. We're going to talk about estimation. And estimation is the process of arriving at an approximate answer to a question. Companies estimate the amount of their products consumers are likely to use. Economists estimate financial trends. And if you're about to cross a street, you may estimate the speed of oncoming cars so that you know whether or not to wait before crossing. One type of estimation is rounding. And sometimes we round and we're not even really conscious of it. You may say that you're 20 years old rather than saying that you're 20 years and 5 months old. Or you might say that you'll be home in about half an hour rather than saying I'll be there in 25 minutes. So those are just some cases in real life where you do estimation. But the kind of estimation we're going to look at is rounding. To work with rounding, you have to know place values. So I'm sure you're familiar with this already, but I thought I would include the place value chart. Each one of these that is designated in a different color is called a period. So the first one is the ones period, the thousands period, the millions period, and the billions period. When you separate periods in a number, in our language, we separate with commas. That is not universal, but it is in English. All right, so we have our place values. Let's take a look at how we can use this. I will enlarge this just a little bit. Number one, according to a survey, 28,474,685 people can speak a language other than their native language. Round this number to the nearest 100, 1,000, 10,000, 100,000, million, 10 million. All right, I'm going to describe my rules for rounding. it says in the first one, round to the nearest 100. I like to go over and underline the hundreds place, which is a 6. Look at the digit behind it, because that's going to tell you whether you're going to round this up to 700 or drop it down to 600. Because the number I have the arrow pointing to is 5 or greater, I'm going to round up. So this becomes 690. So, no, it doesn't. So sorry. I was rounding to that place. I'm supposed to be rounding to the hundreds place. So that will be 700. I apologize for that. Any numbers, any places to the right of where you rounded must be zeros. Okay, let's look at the next one. I'll be more careful. All right, we have the same number, but this rounding to, just one second. We're rounding to the nearest 1,000, and the 4 is in the thousands place, so I look at the 6. Because the 6 is 5 or bigger, it is bigger than 5, it's going to have me round the 4 here in the thousands place up to 5. So again, it is 28,475,000 and finish with zeros. Next, I'm supposed to round to the nearest 10,000. Well, 7 is sitting in the 10,000s place. The 4 tells me to drop it down to 70,000. So I will get 28,470,000. If the number where the 4 is right here, if it had been 5, this would have rounded up to 48,000. All right, so remember, past the place where you do the rounding, always put zeros. Next, round to the nearest 100,000. 100,000s is this 4. So the 7 tells us what to do. It says to round up. So the 4 will become a 5. So it is 28,500,000. And that's it. So now those are all zeros. Next one, round to the nearest million. 8 is in the millions place. The 4 tells me to not round it up, so it is 28 million and then 6 zeros. You certainly don't need to write that arrow. I'm just showing you that past the position that you rounded, you always get zeros to the right. Okay, last one, to the nearest 10 million. 2 is in the 10 millions place. This 8 tells me to round up, so that will be 30 million. All right, let's look, and I'll shrink this back down so you can read everything for number 2. It says, obtain an estimate for the following computation by rounding the numbers so that the resulting arithmetic can be easily performed by hand or in your head. Then use a calculator to perform the computation, and then analyze it. How reasonable is your estimate? All right, now I need to read this. Round the 2 numbers to the nearest 10. If they don't tell me that, I really don't know what kind of rounding to use. So when I have 349 and I round to the nearest 10, that is 350. If I have 587, to the nearest 10 is 590. Now, if I'm going to add these rounded numbers, that means that I have 0, 14, carry the 1, 940. If instead I find the actual sum, I will get 936. I had already done that, so I could just write that down. So that's 936. How reasonable is your estimate? Now I'm going to choose one of these, reasonable or not reasonable. The actual sum was 936. I got 940. I think that's reasonable. So I will not choose that one, and I will not choose that one. Then it goes on to say the estimate seems a little higher. The estimate seems a little lower. Well, the estimate's 940. The actual sum is 936. So the estimate seems higher. So I will use choice A. All right, let's look at the next one. The instructions are exactly the same, so I'm not going to reread those. This time it says round each number to the nearest integer, and that is a whole value, positive or negative. Well, these are all positive, so 8.61 rounds to the whole number 9. So when it says integer or whole number, it is to the nearest 1. The ones place. Okay, 4.28. I'm rounding to the ones place. The 2 tells me to leave it. I don't have to put zeros because they would be behind a decimal point, and I'm not doing any decimals. And finally, I have 15.14 to the nearest 1. That 1 says just leave it, so that's 15. All right, so that gives me 13. That gives me a sum of 28. That is my estimate. Then I need to do the actual, and I can either do those by hand or I can type it in my calculator, and I get 28.03. $28 versus 28.03. Once again, I think that's very reasonable, so I'm going to mark off those two. The estimate this time is just a little bit lower than the original, so I will make that be choice D. All right, number 4. It says, determine the following estimate without using a calculator, and then use a calculator, and so on and so forth. Those are the same instructions. It says you lease a car at $402 per month for 3 years. Estimate the total cost of the lease by rounding the monthly payment to the nearest 100. All right, the monthly payment is $402. If I round that, I'm going to have $400. Well, I am supposed to estimate the total cost. You have to be careful. It is it's $402 per month for 3 years. Well, there are 12 months in each year, so for 3 of them, there will be 36 months. So, all right, so I have 0, 0, 24, 0, 0, 12. I'm sorry that's gotten very messy, but I have 1, 4, 4, 0, 0. 14,400 is my estimate. If I multiply 402 by 36, and I did it with a calculator, I would get $14,472. So 14,472. All right. It's a pretty reasonable, considering the size of those numbers, they're not very far off. The estimate, is it higher or lower? The estimate's a little lower. This one says, by how much? Well, the estimate, 14,400, the actual, 14,472, the difference is $72. All right. Last question. We're going to do some estimating using some graph or a graph. All right. These are the results of a survey. According to a recent survey, in 2012, almost a third of the country A named country B as their greatest enemy. The line graph to the right shows the percentage of citizens of country A who consider C or B their country's greatest enemy from 2001 to 2012. All right, let's just talk about this for a minute. The horizontal axis goes from 2001, 2, 3, all the way up to 2012. The vertical axis is the percent of the citizens in country A that believe a particular percentage. It's the percent of those citizens that believe this line, they believe country B is their greatest enemy. This line, they believe country C is their greatest enemy. Okay, question A. Find an estimate for the percent of citizens of country A who consider country B their greatest enemy in 2010. All right, 2010 is right here. Country B for 2010 is right there. Now, that looks, it is above 25, but this one looks maybe like it's 26. So I'm going to have to say it looks like 27% to me. Then it goes on to say, between which 2 years did the percent of citizens of country A who considered country B their greatest enemy increase at the greatest rate? All right, so once again, I am only looking at the country B data. Now, the greatest increase will be the steepest joint in the line. And the steepest joint is from here to here. And that occurred from 05 to 06. Okay? And then final question, in which year did 9% of the citizens of country A consider country B their greatest enemy? 9%. Okay, 9% has to be lower than 10. So there's this and this. That's exactly 10. That's exactly 10. That's lower, but that's even lower. I would have to guess that this is about at 9%, and that is occurring in the year 2002. All right, so we have talked a little bit about inductive and deductive reasoning, but done our problems on estimating, either visual estimating or using rounding for estimating. So hopefully you can do your homework.